project, the xRemote. xRemote is a small and inexpensive multi-device remote control hub, which can be controlled by the smartphone application. And it integrates, it's designed to control all the infrared control devices through a self-learning and reverse coding mechanism designed by our engineering team. So it also integrates, it will also integrate Bluetooth and Wi-Fi module, so it can control other smart devices. This feature also allows you to control your household appliances and devices from anywhere in the world where the internet access is valid.
My project is about performance characterization of JavaScript applications, and what we're trying to do over here is that we have two types of languages, basically dynamic languages and static languages. And with dynamic languages, there's always this question of their speed, how fast these languages are. And just-in-time compilation is a very important feature in dynamic languages, which really helps in improving the performance. And what we are trying to ask is that, is it possible to improve the performance of JIT, or just-in-time compilation, even further? And the feature that we are looking at is adaptive optimization. What JIT does is that it profiles the functions at runtime and tries to identify the hot functions and then recompile it with better optimization flags. So what we are trying to say is that can we tweak that a bit, or can we improve that a little bit? And with our ideal graphs, with our ideal calculations, we found that yes, it is possible. We conducted some experiments and we found that it is possible. And what we can do is that right now, JIT applies the same level of optimizations for all functions in a benchmark or in an application. But it might be that different functions are suited better for different optimizations. So we cannot just go with all the optimization flags for a given function. So our job basically is to identify or to classify functions and map them to a given set of combinations of optimizations. And the first thing that we did was a brute force method. We have a dedicated server and we have the standalone V8 application. The V8 is basically something that runs inside your Google Chrome. And we ran scripts to apply all the optimization combinations possible and see the results. And we got pretty good results for at least some of the benchmarks in V8. And in the next step, we tried to hack the V8 source code because it's open source. So we used the data that we got from our Oracle, and then we tried to actually change the code a bit and see the performance that we get. And for some of the functions, as you can see, this is the default case where it takes around 1,000 ticks for one of the functions. But with the ideal case it's 35, and with our hacking it's around 84. And so okay, we did not get the expected value of 35, but close enough. And in the next and final step that we did was to have this all done automatically using some sort of a machine learning technique. And the machine learning technique that we have used is SVM, output vector machines. And currently it's done offline. So we basically give it some benchmarks for training, then we get a model, and then we provide some testing data, and then we have a classification. It basically makes a prediction. So we have used that prediction to actually again then go and change the V8 source code and then see the performance, and that too is pretty good in some of the functions. But there are some functions which are weak yet, and we need to identify why that is so.